Hey, how's it going? Here's some information on different theories of the universe and what it may entail. Since the center of the universe video was a little short, here's a little add-on, a bonus. Let's begin. Brain world cosmic strain. An aspect of the universe we take for granted is that it's 3D. There are three directions you can move on. Some theories, however, suggest another spatula dimension we can't directly perceive. In another direction, this higher dimension space is referred to as the bulk. While a universe is a 3D membrane, our brain floating inside the bulk, as complicated as it sounds. The brain world picture solves several problems in physics. For example, theoretical physicist Lisa Randall of Harvard University and Roman Sandra of the University of Maryland proposed a version of the brain world that explains an asymmetrical in subatomic forces by suggesting the existence of other brain parallels to our own. But it's not enough for a theory to explain facts we already know. It has to make new predictions that can be tested experimental. In the case of the Randall-Sutter model, such tests can involve measuring gravity waves emitted by black holes, linking one brain to another. The Big Splat Theory. In the far future, galaxies will eventually drift so far apart that light will never reach from one another. In fact, as stars get old and die, a time will come when there's no light or heat left. The universe will be a dark cloud, a void, emptiness. It sounded like the end of everything, but according to one theory, it actually is the beginning of the next universe in a repeating cycle. Remember the brain world theory. This is what happens when one cold, empty brain collides with another, which given enough time, it bounds to do eventually. Cosmologists Neil Turek and Paul Schneider believe such a collision would generate enough energy to create a whole new universe. They call this the epoch theory. Through physicist Miko Kuo has more emphatically dubbed it the Big Splat. Plasma-filled cosmos is another one. The Big Bang remains the preferred theory of many scientists, supported by two key observations: the expansion of the universe and the cosmic microwave background. Immediately after the Big Bang, the universe was such a small and hot boiling point, filled with a glowing plasma like the sun. We still see the end of this super hot plasma phase in the form of sea of radiation filling the whole of space. The expansion of the universe over the billions of years has cooled the radiation down to minus 454 degrees Fahrenheit, but it is still detectable by the radio telescopes. The cosmic background looks virtually the same in every direction, which can't be explained if the universe has always expanded at its current rate. Many scientists believe it went through a brief period of extreme rapid inflation, a fraction of the second after the Big Bang, suddenly ballooning in the size of subatomic scale to several light years. The holographic universe is another one. I find this quite interesting. It's like the Matrix. This is basically a 2D object encoding a full 3D image. According to this theory, the whole 3D universe may be encoded on its 2D boundary, sort of like a projection screen. It may not sound as exciting as living inside a simulation, but it has the advantage of its scientific testable theory. Research in 2017 from the University of Southampton, UK, showed it was consistent with the observation pattern of the fluctuations in the radiation in the universe. The steady state universe is another one. The Big Bang is our best guess on how the universe started, according to NASA. It was denser in the past and it will become less dense in the future. Not all scientists were happy with that, so they came up with a way of density to remain constant. Even in an expanding universe, that resolution involves the continuous creation of matter at the rate of about 3 hydrogen atoms per cubic meter per million years. This model fell out of favor with the discovery of cosmic radiation, which the model can't easily explain. The multi-universe, such as the new Spider-Man film. In the conventional view of the Big Bang, in order to explain the background radiation, it is necessary to postulate as a super vast expansion of inflation. Some scientists think the universe dropped out of the phase. It was just one tiny bubble in a vast sea of space. In the theory called eternalflation, proposed by Paul Steiner, other bubble universes are constantly popping up in other parts of the sea, with the whole ensemble making up a multiverse. The theory gets even stronger because there's no reason other universes should have the same laws of physics as ours. Some might have strong gravity, some different speed of light, although we can't observe the other universes directly. One of them could collide with our own. Scientists have even suggested the cold spot in the imprint of the universe of a collision. Another theory is we got gravity all wrong, and our galaxy is surrounded by dark matter. Or is the theory of gravity wrong? Theories of the universe depend on an accurate understanding of gravity, the only force in physics that affect matter on a very large scale. But gravity alone can't explain certain observations. If we measure the speed of stars on the outskirts of a galaxy, they're moving too fast to remain in orbit. If the only thing holding them back is the gravitational pull of the visible galaxy, similar clusters of galaxies appear to be held together by a stronger force that we can be accounted for by the gravity of visible matter. There are two possible solutions. The standard one, favored by most scientists, is that the universe contains unseen dark matter, which provides the missing gravity. The maverick alternative is that our theory of gravity is wrong and should be replaced by something called modified Newton dynamics, or MOND. Scientists proposed in 2002 in the journal Annual Review of Astronomy and Astrophysics. The two options, MOND and dark matter, are equally consistent with observations but are yet to be proven. More experiments are needed for this theory. Another theory is superfluid spacetime. Aren't you enjoying this? I surely am. Isn't that fun? Yes. So superfluid spacetime, even if space only has 3 dimensions, there's still a 4th dimension in the form of the universe. So we can visualize the universe existing in 4D spacetime. According to some theories, like one proposed by Stefan Liberty of the International School of Advanced Studies and Luca Mocon of Ludwig Maxwell University, sorry if I butchered that was quite a long word. In the Physics Review Letters journal, this isn't just some abstract form of reference, containing physical objects like stars and galaxy, but a physical substance in itself, analog to an ocean of water. Just as water is made of countless molecules, space-time, according to this theory, is made up of microscopic particles on a deeper level of reality than our instruments can reach. The theory visualizes space-time as a superfluid having 0 velocity. An odd property of such fluid is that they can be made to rotate in a wholesome fashion, like an ordinary liquid does when you stir it, which in the case of super space-time may be needed for making galaxies. Simulation theory is another one. Do you have all this written down? I sure hope you do. So far, all the theories have come from scientists, but there's one form, the philosophers. If all of the information about the universe comes into the brains via our senses and scientific instruments, who's to say it's all an illusion? The entire universe might be nothing but an ultra-sophisticated computer simulation. It's an idea that popularized by Matrix. Even though it seems outlandish, a lot of philosophers are taking it seriously. However, it fails the test of the true scientific theory because there's no way it could be proven or falsified. Well, wasn't that fascinating? Did you learn a little bit? Is your mind blown? Please let me know down in the comments down below what you think the universe is made of, or what is the universe per se. Do you think there's a god? Do you think there is a multiverse? Do you think there's multiple versions of yourself out there in the world, going on different expansions of options that you might have come across, such as, did you get that job? Did you get that woman that you wanted? Did you travel to that place? Did you die a long time ago? Let me know down in the comments down below what you think. Thank you and have a great day.